Good afternoon, dear students. Again, today we will start with lecture part of Medical Informatics and Biostatistics course, and I will try to present for you first lecture with which will talking about introduction into medical informatics. My name is Andris Cybernetics, and I am Associated Professor of Medical Informatics Department of our university. And probably have to admit that probably we will meet again on practical classes with me or with my colleagues as well. Okay, let's start with today's topics. So I have to understand that medical informatics now it's very broad area for scientific study and for scientific activities. And right now, within the course of this lecture, I will try only provide some basics. And in fact, lecture consists of two parts, when in fact I will be more concentrated on theoretical definition of what is medical informatics and related areas and subfields, rather than in second part I will try to provide also brief introduction into one of the practical implementation of medical informatics activities, telemedicine. So for sure we will talking about theoretical question around telemedicine. And now move on into part one about what is medical informatics. So definition, areas of scientific studying, related scientific areas I will try to present for you, some aspects of major activities, scientific activities under medical informatics area, and a quick overview and definition of few subfields and subspecialties under general medical informatics, and also finally definition of cybernetics and medical cybernetics and main area of studies, because in fact it's very difficult to distinguish medical informatics from medical cybernetics. That's where they are very tightly joined together. Okay, before we will talk about medical informatics, let's recap what is informatics itself. I have to have some basic definition knowledge from school, and in fact lots of various definitions available. So here is one of shortest and possible. So informatics is the science and art of turning data into information. So we have ability to observe and collect a lot of data about universe around us, and but it's not all this have matter for us in specific circumstances, especially if we talk about medicine and medical diagnostics. So we need to turn it into information. We need to gather important facts, important things from there, and it will be areas of studying for informatics. So when we talk about informatics, at every time intersection of these three things: data, systems, and peoples, because we are now living in technological world, and our data are every time supported by systems, and we as the people every time interact with data through various systems. It's even like right now in this distance lecture. So if we talk about more broader and more scientific definition of informatics, so it's broad academic fields which comprise human-computer interaction, information science, information technology, algorithms, and social science. And it's include information science itself, which is study of processing, management, and retrieval information, and computer science as part of in general informatic fields. It's the study of complex system information and computation using applied mathematics, electrical engineering, and software engineering techniques. So informatics, information science give for us theoretical background, which is again gathered from mathematical area, and computer science gives us ability to implement it that's methodologies of information, data processing and tuning information with specific solution based on computer systems and software solution. And information technology, as again broad term, it's study, design, development, implementation, support, and management of computer-based information systems. So modern time, when we talk about informatics, computer science, information technology, we every time refer to computer-based information system. But in fact, we can talk about informatics and information technology only as pure academic fields, and it was exist for years, decades, even prior computer has been made and developed, and it was work and was considered only as theoretical scientific area. Now turn closely to medical informatics. What is this? So I will try to show a few definition which is changed during time, and despite history of medical informatics count about maybe even up to 60 years as scientific studies, I will just start from 1984, where we will have like some maybe definition which is given some sort of definition like finalized and completed definition. So first of all, we consider at those time medical informatics had been considered as science of using system analytic tools to develop procedures, algorithms for management, process control, decision making, and scientific analysis of medical knowledge. So, as we can see, there is nothing about computer system, there is nothing about patients. We are talking about development of the procedures, algorithms, and emphasis on algorithms had been made, and scientific data analysis. That's all. It was not very old point. It was like about 35 years ago, 36. Same year, another author, also well-known professor in the medical informatics area, consider medical informatics as theoretical, which scientific area which comprises theoretical and practical aspects of information processing and communication based on knowledge and experience derived from processes in medicine and healthcare. So again, we are talking about theoretical investigation, theoretical scientific data analysis, and again, nothing about computers or patients. But about 15 years later, at the end of 20th century, the same person in his very known printing handbook of medical informatics define medical informatics in another way. So in medical informatics, we develop and assess methods and systems for the acquisition, processing, and interpretation of patient data with the help of knowledge that it's obtained in scientific research. So again, starting from the end of 20th century and up to now, focus had been changed, and now solution which is dedicated to provide healthcare, improve healthcare for specific patient taken into account. So here is what is fast for the first time presented in this definition. It's term systems, and also it's noted that we deal with a specific patient, with patient data obtained from specific patients. So again, before it was time to collect methodologies, to develop methodologies, and within last 20-25 years, it's start time to apply it in behalf of benefits of every patient who can access this kind of services as well. And few more narrow definition, for example, from 2012, we even terminology altered from medical informatics to more generalized health informatics, of which health informatics is application of technology tools and information system in healthcare settings or context, where under technology tools. We could see any computer hardware, software solution, and on the health information management systems, we understand things like methodologies for records, coding, documentation, policies, guidelines, administration, compliance, and all other related things, organizational things, which is absolutely necessary to be operated and implemented along with a computer system in order to bring health informatics and health medical information system to work. So another definition which could be found on the midline, for example, here we can see medical informatics like interdisciplinary study of the design, development, adoption, and application of information technology based in innovation in healthcare services delivery, management, and planning. So here is again we have that things about information technologies, and we have significant emphasis on organization management there. And it deals with resource device methods required to optimize acquisition, storage, retrieval, and use of information in health and biomedicine. So again, we have then things about that same things like acquisition, storage, retrieval, and usage, process information, that these words will be repeated multiple times in definition of medical informatics or its and maybe one of the latest definition we can see here is separate definition for healthcare informatics and medical informatics, which is again very similar. So we can see healthcare, medical informatics as a field of science and engineering, that apply informatics fields to medicine in general, and medical informatics we can see as spectrum of multidisciplinary fields that include study of the design, development, application of computational innovation to improve health care. And disciplines involves combination medicine fields with computing fields. So in all this case, in modern definition, is extremely hard emphasis made at statement that medical informatics, healthcare informatics, it's multidisciplinary fields. It's not something standalone. It's intersection of multiple area when you try to gather methodologies, knowledge, facts, data, and combine it all together with one final goal: improve healthcare. Bring innovation from all area, special information technology area, in order to improve healthcare. If we want to use like things colored line diagram, we can denote major backgrounds of health informatics in this form when we have this triangle: healthcare, information science, and computer science joined together with mentioned goal before. So information science, as well as its descendant mathematics, various mathematical areas, give for us theoretical methods for data manipulation, classification, processing, and so on. Even if you talk about storage, retrieval, so here is only theoretical approach how it's possible could be done. And computer science give for us ability to transform those general algorithms, general approaches, in form at least to, for example, in form of algorithms which could be executed with final goal, with strongly defined final goal, step by step, and those algorithms in turn could be implemented with like via programming languages and run it onto specific computer systems, so we can get some final product which could be used for our day-to-day activities. For example, it's one of the possible solutions. All those communication and information technologies and software solutions which made possible this distance lecturing. That could be offered for you by me. As I repeat again, that's medical informatics multidisciplinary studies. and it's applies methodology developed in multiple areas of science, endeavor to many different tasks. And at the right side, you can see how we can distinguish various areas, for example, only on intersection of genomics as biological studying and general medicine and informatics. So, and we have like at least 4 different subjects bring to board from this point, and 3 of it's related to medical informatics, like bioinformatics, biomedical, and medical informatics itself. So they are not the same things, despite they are extremely close. But when we make emphasis on scientific investigation and in biology, our works will be classified under, will be related and classified as bioinformatics activity. And when we take into account some personal patient data and patient genomic data collection, so we will deal with biomedical informatics in this case. Also, if we will consider subfields and sub-areas of under general medical informatics, we can display it in various forms, like descendant tree-like structures, when we can depict the relationship between different areas, specialties, and the medical health informatics, and actually what is different between health, medical, and clinical informatics. And even up to public health informatics. Or another version of Venn diagram could be presented, and which helps to understand which area cover more generalized question like healthcare or health informatics, which covers all activities including public health, medical education, social education, hygiene prevention, so all those things covered under healthcare information. When in medical informatics we covered only question and discovered and studied questions related to medical application, and with clinical informatics we are limited only with usage of information technologies in healthcare facilities, and so on. So here is like parent-child relationship very fine to be depicted with Venn diagram. As of about aspects of the medical informatics field's activities, we have plenty of this, and this slide only present 4 from that set, which is not finite, but actually most common and widely very fine, visible, and useful. So first one is obvious. It's architectures of electronic medical records and other health informatics information system. Actually, if you talk about implementation of information technologies, that it's first thing that will be visible for everybody. It's some sort of computer-based information system, software solution, which is dedicated to, for example, automate day-to-day routine, create electronic patient records, collect medical images in digital format, and so on. But next important, and actually it's major area when today's scientific activities has been performed, it's development of decision-making process, so creating decision support system, expert system, even up to artificial intelligence. So that's things which is area of active study, and it's like most interesting area up to now. But this top pair of aspects of activities under medical informatics will be impossible without bottom pairs, without very hard and very difficult work which is dedicated to creating various standards which made possible interaction between different digital system. So like I mean about standards dedicated to store and manage medical images like DCOM or electronic medical records, which is part of Azure 7 now, and so on. So without those things, it's impossible to build effective medical information system solution or decision support system. In turn, to be able to develop standards, we already must have sort of limitation standardization in our knowledge collection, in our knowledge base, and so on. And all these things achieved already with controlled medical vocabularies, with using of medical classification system. So there actually it will be objective for the second lecture, and right now it's only give for you this point as a point about importance. So to be able to build house, we must have some background for it. We must have some basement, and actually it's basement. It's all those medical coding classification system vocabularies like. SNOMED and also and similar things. Without it, impossible to develop rest of all these components. So if you want to know more about subspecialties in the area of scientific and practical activities under medical informatics, I would recommend for you to check this slide. Unfortunately, at Moodle already uploaded only a little bit older version of this presentation, but after lecture I will replace version of presentation, and this slide contains multiple links just to Wikipedia. It's just a good starting point. It's not very reliable source, information source, but it's a good starting point to begin investigation. And you will be able to read more about various subspecialties under medical informatics, which is in active, which have great activities now. And the following chart could give for you some essential about complications of under medical information exchange and diagnostic processing cycles, how it's be going on. So for sure, in your practical activity, you will be interested to deal with specific patients, so individual patient. It's have to be subject for investigation, and what you will do it investigation against what. So it's have to be knowledge base that you will absorb through this education as well, from various textbooks, from various medical guidelines, protocols. So from this source, which is at the bottom in the center of the chart, like which represent the rule base and which is collection of information in medical area obtained during decades and hundreds of years. And for sure important source information, it's previous cases, like background for today's evidence-based medicine. We rely not only on like verified textbook, but we also have to take into account known cases and their outcomes, which give us significant amount of information and on diagnostic and treatment for specific case and a specific condition. So that's case base, it's critically important. And when you resolve issue with your current patient, it's become component of case base, at least in your own practice. Or if you will also find something interesting and will publish, for example, scientific research, which will describe this current clinical case, it's become available for other physician as component of case base. And so when you verify and analyze data obtained from specific patient against noun and against knowledge base that's available for you, through reasoning, you can come to some solution about therapy. We find it will be personalized therapy, so based on given protocol, but with necessary adoption. and it's to be uploaded for patients. Then you verify resource of treatment, and cycle will be repeated a few times until hope successful end. Sometimes happens in successful cases also, but that's life. So also, if I will make like step forward, even I assign if we have reached this cycle of information processing, when we collect information, analyze it, develop some control measures, apply it, and repeat cycle again. So we make our steps from clear informatics into next area, into cybernetics. In fact, but it will be a few minutes later, and I will continue on this. So again, if I will repeat this like a little bit again, consider again more closely diagnostic therapeutic cycle. So here as we have, as I already said, data collection, which we can get from patient, and with modern diagnostic methodologies, we can retrieve plenty of data about current state of patient health. We are not limited only of visual observation. We're not limited with hearing patient complaints, but we can got lots of physical examination and laboratory tests, and it's very hard to manage all this without all this data, without proper without recording it within like electronic systems. And in fact, electronic system helps us to gather this data, like specific laboratory equipment, imaginary equipment, all this special information system give us data. Then we can aggregate those data into medical information system, and maybe not all those data, but maybe only essential and important fact from it, which is information in turn. So we can collect a lot of, but not all the things make sense, and only that fact which is makes sense give for us information, give for us something significant about patient state, which will give for us ability to make decision by yourself, or maybe with help of modern clinical decision support system, expert system. There are already lots of available, some for free, some professional, definitely every time on the commercial subscription. And it's give for us internal ability to make some therapy planning, which is typically reflected as prescription, have to be reflected as prescription and under medical information system implemented by patient himself with assistance of nurses or other professionals. And again, you will need to collect new data with the help of physical examination laboratory equipment, and then analyze it in order to get significant facts, information, and repeat this cycle. So beside of all these ellipses, we have name of conventional types of medical information systems, various tools which could assist physician and medical professionals in during this processing. And just to check, to move a little bit into practice, we have to just compare like various achievements in technologies which is changes during last 40, 50 years, 100 years, for example. And here is only about progress in information technologies itself and storage capacities. 50 years difference between these photos, so we need to track and trying to deliver 100 megabytes storage into London hospitals 50 years ago, and actually a picture of a micro SD card, which is in fact already, it's taken like 2 years ago, it's already outdated. No 1 terabyte on micro SD, it's no problem now. So here is, it's only 50 years in storage capacity. And another example, we talk about how practically could look like all this. That's things I abbreviate, I provide for you, like MIS, AHR, and so on. Actually, we have separate lecture about medical information systems, and it's only a few pictures how we look like electronic medical health records, or electronic health records within integrated system which supports everything up to uploading medical images and some analytical measures, how it's look like for dentists even, or how professional medical imaging system could look like and what it could contain. And actually it would be fine to see it in online, because typically it's contain dynamical features and provide three-dimensional visualization and so on. Now, very quickly, I will try to pass through the few definitions of subfields of medical informatics. So now, of medical and health informatics. So now turn into clinical informatics. It's have to be seen as subfields of medical informatics, and it's combination again of information science, computer science, clinical science, designed to assist and management and processing data, information, and knowledge to support practice and delivery of clinical care in clinical facilities, for sure. So we are limited with clinical facilities here. So it's this internal cycle, you see, internal ellipses in yellow, you see at given Venn diagram. Biomedical and bioinformatics. I have already introduced it and shown in Venn diagram how it could look like, but again, just repeat. Biomedical informatics concerned with study and application of information technology and computer science, as well as decision-making, human problem solving, cognitive science, standards, policies, and human factor perspectives of biomedical science, medicine, and healthcare. So it's we take into account patients there. We process patient biomedical data, especially genomic data. In bioinformatics and computational biology involve usage of techniques including applied mathematics, informatics, statistics, computer science, artificial intelligence, chemistry, etc., to solve biological problem, usually on molecular level, and it's aimed to academic research primarily. So, major difference, as I already said, that's biomedical informatics. It could be used in clinical facilities. Bioinformatics, it's an area for studying under academic research. So, and if we again check within another angle, look into intersection of health informatics, biomedical and bioinformatics, here we can enlist specific studies, specific activities under all three of this. So actually, what I can say is that within this subject we will make significant emphasis on question related to health informatics during practical classes, for sure. I mean, and actually, in fact, we already under telemedical process to be clear and strong on the telehealth process right now, but it's about this more detailed in a few minutes. Also, we will have some activities on the medical information system, decision-making process, yes, computational analysis, statistics, so that question will be considered during practices by various examples, typically not very difficult, and especially solution will be application software. I will try to use as simple as possible, like spreadsheet. So bioinformatics question, it's out of scope of this subject, which is important. So informatic technologies definitely have to be used there, but it's out of scope. And if you expect such studies, for sure you will get part of it, but at other departments, not at our department. Okay, public health informatics could be defined as systematic application information in computer science and technologies to public health practice, research, and learning. So, major tasks: collection, storage, analysis of public health data, promoting of various healthcare activities, and so on. Like, importance of this area grown, actually skyrocketing within last 1.5 years with this global pandemic, as well as importance of application of proper various social measures. So here is area of studying, and in fact we have significant failure of most of governments under this area. Underestimated activities, and actually significant lost we have, which is led to loss of lives definitely. Same way we can create definition of medical informatics, which is related to any medical specialties. Here given for nursing, but in same way we can change only name of medical specialties and got definition of their professional medical informatics science area. And already available a lot of it under all major medical specialties. I will not provide this definition because they every time copy one of another. Medical cybernetics. So before talking about medical cybernetics, just few words about cybernetics in general, which is actually difficult to understand things. And I have to admit that I am not professional in cybernetics, so despite I'm interested and working and have some even scientific publication which could be related on the medical cybernetics, but so my primary area is electrical engineering. And cybernetics is a disciplinary study of structure of complex systems, especially communication process, control mechanism, and feedback principle. And cybernetics is closely related to control theory and system theory. So again, we have to understand that control theory, system theory, it's again independent scientific areas of studying. And concepts studied by cybernetics include and not limited learning, cognition, adaptation, social controls, emergence, communication efficiency, efficiency and interconductivity. Maybe to move quickly forward. So what is key in the cybernetics? That we consider everything as system, and system which is interact with universe through informational process. So we consider a relatively simple principle when we got some measures from system, decide about changes in how to control the system, apply that control force, make new measures of feedback, provide assessment of how effective, how good is our control intervention, and decide about how we can change it. And repeat this again, repeat the cycle multiple times. And it's why I'm talking about similarity between diagnostic therapy cycle with cybernetics. Yes, because it's cybernetics, because it's cybernetical management of patient clinical case. So pure cybernetics studied systems of controls as concept, attempting to discover the basic principles underlying things like artificial intelligence, robotics, computer vision control system, emergence, learning, optimization. And computer science directly applies concepts of cybernetics to the control of device and analysis of information within areas of decision support system, cellular automation, simulation, including simulation of biological objects, cell tissues, whole organism, and so on. And again, so it's thankfully because that pure cybernetics provide maximal level of abstraction. System like input, output, control force, feedback, and so on, the things which we deal with under cybernetics. And medical cybernetics, actually, definition of general cybernetics come from biological objects, not from technical system. Norbert Wiener, who is founder of cybernetics, give it stroke. It's at the bottom, given his statement, which is defined cybernetics as a theory of communication and controls of regulatory feedbacks in technical system or in live biological object, animal, human. So for cybernetics, there is no difference what we deal with. Is it we're talking about technical system, some sort of machine, or we're talking about biological object, again, cell or organism, no matter. Is it we talk about social group, we want to manage it? Okay, that is system. That is cybernetical system. And we can see aim of cybernetics is the recursive process of creating stable state. When something, some force provide input for that system, like change its state from stable to unknown, probably unstable, internal feedback, internal forces or internal mechanisms looking for some solution for stable state and create some output which is implemented by system itself or have to be done by some external subject who is in charge to manage this system. So simple case, like when we talk about cyberneticals here is, which is depicted at the right side, when it's how our senses work when we like touch something hot or something with fingers. So we got information input which can give us about potential unstable states, reach us control center, our brain, we developed feedback, and then it's information sent back to execution force, which is us muscles take our hand back out of it and so on. But it's purely as a cybernetical system works. So, cybernetics in biology is study of cybernetic system presented in biology organism, primarily focusing on how animals adapt to their environments, or second approach, have information in form of genes or biochemical signal passed from generation to generation, passed from between tissues and organs and so on. And activities on the medical cybernetics, it's already available number of it. It's bioengineering, biocybernetics, bionics, medical cybernetics, synthetical biomogy, study of homeostasis, and so on. So even if we talk about medical cybernetics, we have to understand that it's not something single one. It's like combination of multiple areas already. So finally, we can come to definition of what is medical cybernetics as one of general as fields of among other cybernetical areas of activities. The fields that apply cybernetics, which utilize concepts of cybernetics to medical research and practice. And major topics on the cybernetics, it's system theory in medical science, which is dedicated to searching for and modeling of physiological dynamics, so creating that model which will, with enough reliability, represent various elements, cells, tissues, bodies, or medical information and communication theory, which describes signal process information storage in different physiological level, or connectionism, or studying of neural network, and decision theory, which is gather evidence-based foundation decision-making and clinical settings, so how we can make decision about diagnosis or so. And finally, after all this definition, I turn back to some aspects of medical informatics fields. And here is we have like summary about what is focused like the traditional and modern medical informatics when in information age healthcare have to be actors which work in healthcare area have to be made emphasis on telemedicine, on cybernetics, on prevention, self-help, and self-help, self-care, assistant care, and so on. So here is we have to working with remote remote activities, retrieve that data remotely from patient, and then even if possible automatically provide assessment, develop recommendation, and so on, and only under supervising of medical here healthcare professionals, and with final goal it's consumer health improve improve and develop personalized healthcare. So we have focus at consumers and each one patient needs with this approach, and try to fulfill it as quickly as it's possible. Like in previous decades, major emphasis had been done for medical providers, for fulfill needs hospitals, ambulances, and so on with their equipment and equipping and running with various information technology solution. So now emphasis changes to bring solution closely to individual patient, and if possible to do necessary activities and even remotely. Again, year of COVID pandemic, long lockdowns, limitation for access healthcare facility, in fact, give enough proofs that it's possible. It's not immediately, and not everything working good, but significant part of healthcare activities could be done remotely, and we have this already proved. And here is also one important consequence, and that things which is works every time. That's each year we have like enlarging role of automated system more and more. So here is we have trend we're given with this arrow. So almost each year more and more artificial solution has been developed for assist physician in diagnostics, decision making, in even up to research and development. So another consequence of these things that it's a more strong competition on between on human resource area to be hired, especially in high developed countries. You like physician, future physician, healthcare professional, new healthcare professionals must demonstrate outstanding skills and capabilities, because that's routine activities very often has been automated. Had been automated. Other hand, I have to admit that another consequence, it's every time like shortage of low-level medical staff, nurses and other assistants, because some things decision-making could be automated, but somebody can like assist patient with various very personal activities. Now move into second part of lecture, which is related to telemedicine, which is related to practical application of one of the most valuable practical application of information technologies and communication technologies into medicine. So its ability to provide some kind of services remotely. Within this part, I will try to provide definition, objectives, some classification of the medical systems, components of it, and maybe a few words about terms as like robotic surgery. Telemedicine should be obvious from this word. It's usage of telecommunication information technologies in order to provide clinical health care at a distance. Actually, emphasizes its clinical health care on the telemedicine itself. And telehealth, like very tightly related term, refer to clinical and non-clinical services and involve medical education, administration process, and research, included everything related to public health activities and healthcare management. So, as I already said, just delivering of this lecture on medical informatics online make us all, so we are involved in telehealth process right now. So could be maybe again that's within last lockdown years, it's become like almost routine, such activities, but still we have this term that could define what we already do, what we right now do. Now, main objectives of telemedicine. So, from definition of words, first of things, user when he hears about telemedicine, it's like something like kind of video conference between medical facilities. It's for sure one of outcome of telemedicine, but if you talk about objectives, so at first place it's transferring all kinds of medical information, image, video, audio, and for sure even alphanumerical text-based records. So if we have ability to send data record and got some response, we are talking about implementation of telemedical process in clinical workflow in clinical activities. And second objective, supporting of medical specialist collaboration process with clinics, so hospital physician, and even patients. And it's included both online and offline methodologies. So even when we call to, so like well-known things, call to family doctor and ask about claim about bad feeling and ask about maybe you can recommend something. Okay, it's already telemedicine. So very often had to be done without and this knowledge. Same way if it's online, again, send request and got response. Here is we talk about via success in implementation of telemedicine in our practice. So in this case, if you look in historical review, even in ancient world, it was available. So if it was like create new some remedy, recipe and send it from one city to another, from one tribe to another, if it was become possible to like denote it on some paper or so, and send it even with horse or man. Okay, so we complete with some fast objective, transferring medical information. So no such words, no such technologies available at those times, but it's already working. Slowly, not reliable, but was working. And for sure, everything skyrocketing with inventing of communication technologies like telegraph, telephone, and so give us ability to communicate in real world online communication, not visual, but at least convention, at least audible conversation. And next step had been made with development of space exploration program when it was become necessary of reliable remote monitoring of biological or vital parameters of organ. First we start with animals, then with astronauts. It's become important to got online information about the health condition and even ability to make some intervention remotely. So after all these things become grounded, we got that kind of telemedicine we already have. Okay, classification. Also about classification, telemedical system could be classified according to multiply different criteria. So here is how about their purpose, like store forward, which include acquisition medical data, transmitting to consulting facility and retrieving some response. Remote monitoring when and enable medical staff to monitor patient remotely using various diagnostic devices become very popular with last years, especially through a lot of so-called implants, wearable device, wristbands and other things already developed and available on market, and real-time online conversation, video conferences between patient provider or between various provider, between physicians, which discussed some clinical case. So here is we have one. But we also by function, by scale. Again, the function consulting, control diagnostic equipment, learning, distance learning. So, okay, our model could be considered like part of the medical system as well, and our implementation of lecture also is still in telehealth activity, and so on. And by scale, from home to international level, etc. So depending criteria you want to use, you can classify sources. So usually, as I said, it's look like it's fast, what is imagined, it's like video conference. But as for me, much more practical look like absolutely another approach. So that things when we ability to collect data at some remote rural facility, and then we have ability to get some consulting services, some assistance from remotely, no matter, so we don't need that advanced communication video conferencing tool, but we need some basic communication to send request, receive response. And here as we will talk about success. But as you can see from last message, so maybe other complication could be available, like transfer. Could be a significant problem with isolated area. But anyway, so again, if we talk about some in the past, it was necessary to create something like a telemedical, basic telemedical system, telemedical workstation, or so on. It's typically a personal computer with attached diagnostic device. Okay, it's still possible to be used right now, but more often modern smartphone works as workstation, and all necessary diagnostic devices could be already available on the ambulance or hospital, and just we need to but sorry, it's not so simple as I said. We need to aggregate data into single electronic medical records to send to our consulting office and retrieve some response. In fact, it's still much easier to install even CT machine in Ternopil rather than obtain records from this machine to be able to, for example, send to Kyiv. So anyway, still available lots of professional solution for performing telemedical diagnostic in field, like at left side, or also offer consulting card points like at right side. But it's very like luxury solution, high cost solution, so it's required significant payments. Anyway, right now already lots of smart devices developed, which could and available on market, which could help us in monitoring of vital parameters, collect it, store it within some like central station, and then probably could be used, reused, and send it to family doctor to be analyzed and providing some recommendation. So here is how modern remote monitoring could look like. It's collection via wireless communication channels, collection information from various device, which is typically wearable device, which is available for patient. Patient could afford typically to pay on it, and then aggregate it within some home station or personal station. Usually it's application of smartphone right now. Some available specialized solution like home medical centers, but it's again high cost solution. So, but then we have at right side problematic area. Okay, after we collect this data, it's have to be sent somehow to doctor, and it's we have requirements about like reliability, security, protection of this channel. And here is where like governments have to take their role and get into play and offer like secure communication channel, reliable data storages, or for sure it's could be offered by commercial organization, but this time the services will be not free. I mean, if you are rich enough, okay, that is solution for you, but if you are what if not? As I already said, small mobile phones, smartphones play important role now into telemedical activities, and already available lots of various accessories which like turn smartphone into most common things. It's like portable ultrasound machine available on market for 10 years. Then a various solution to measure ECG. Typically, it's look like wristbands or so, which is could be connected to smartphone via Bluetooth connection, and we can got 1-2 wire recording. ECG recording, but also available other solution, like for example, how to turn smartphone camera into microscope, and it's available professional solutions. So I mean, solution which is classified, considered as diagnostic equipment, as well as this solution and other. Even much greatest variability available among very variable device, so lots of things, dozens, maybe hundreds of models of smartwatches, wristbands already available, sensors built into clothes or other things. So from one side we have lots of way to, let's say, at least the basic vital parameters like this mean heart rate, oxygenation, blood oxygenation level, sometimes CCG. What is important just to take into account that most of those things, it's not a diagnostic equipment officially. So information which is provided by it not considered as reliable enough to be medical diagnostic. And when you check, so as I said, I will replace presentation in Moodle today after lecture. If you will check a given link, so you will see how few of various mobile devices already adopted, legally adopted as diagnostic equipment. So here is a list of few devices adopted by United States Food Drug Administration. or even under specific circumstances, even under threat of COVID pandemic during 2000, during spring of 2020, there are only 6 more devices adopted on for emergency usage. For sure, it's not a full list. It's will be new adoption at the end of years, and previous list also not everything that it's adopted. But what I want to sign at this point, if you decide to like involve some telemedical activities in your practice, you have to ensure that you will be legally cleared for this, to use a specific device or approach, because it could be very critical and cost not life, but at least even up to license or future. And for last point in this lecture, it's introduction about robotic surgery. As it sounds, it's usage of robots to perform surgery. But major advances added by surgical robots have been remote surgery, minimal invasive surgery, and unmanned surgery. In fact, our modern surgery robots, it's not in my opinion, it's not fully robots. They're not worth this term completely, because there is no artificial self-conscious within those systems. That's more likely advanced remote surgery manipulators, which give for physician more degree of freedoms, more even efficiently in various surgical activities. Anyway, so first experiment has to be done that same year. It's why I saw at that period, middle of 1980s. That was placed at first experiment with using place needle for brain biopsy using CT guidance, which has been done automatically. And right now, major stakeholder, major player, it's at this market. It's Intuitive Surgical Company with their Da Vinci surgical system, which is already maybe, if I remember, about 15 years of history, and provide supply multiply complexes for different countries, but it's very costly system. It's $1 million per item. And with each new generation, their features extended with additional capabilities. So usually it's look like 2 components, which one of station for surgery workplace, where he has specific imaging mode and tools which allow to perform remote surgery, no matter what is size, what is distance, almost no matter what is distance between control unit and execution unit, which equipped with multiply hands with different tools, which could be replaceable again. So it's in picture below, it could be done action at the same room, or it could be control and execution tool could be reconnected between different rooms. So this physician could perform activities could work with a unit in even another city or so. So question is only reliability of communication channels and bandwidth, which allow to output signals between that system with video information and precise movement. Again, at link you will have ability to see lots of video, but you can find it same way on YouTube. Okay, and to complete with this, so I still can't pass aside the presentation last year when Elon Musk premiering special surgical robot for implant his so-called Neuralink brain chip. Okay, no, it's already presented, but I look like there is no information about success implanting for us, for humans. Anyway, at least I know that it's working for pigs. So according to his press release, there is success on with animals. Anyway, so here is we have like Grown's concurrent for Da Vinci system. In fact, that's all things I want to talk about this introduction on medical informatics and telemedicine. So, thank you for your attention and have a nice day, have a nice weekend, and prepare for a practical studying on a medical informatics course.